Alright student, this is a numerical problem from the chapter of electromagnetic induction. So in this problem, right, okay, let us read the question. The question says a metallic rod of length L is rotated at an angular speed omega normal to the uniform magnetic field B. So derive the expressions for number 1, EMF induced in the rod, number 2, current induced, and number 3, heat dissipation if the resistance of the rod is capital R. Alright, so here it means that this is a rod of length L, and this rod, it is rotating in a uniform magnetic field B, and let's say the magnetic field B in this case, it is acting perpendicular to the plane of the board. Okay, now this rod, it is rotating with an angular speed omega. Okay, so how to find out the EMF which is induced in the rod, a current induced in the rod, and the heat which is dissipated in this case. So the solution here is, suppose the rod complete one cycle in time, let's say capital T, which is the time period. Okay, so look here, as the rod is rotating in this case, so what happens? The magnetic flux which is linking with this rod will change. So due to the changing in magnetic flux, so then we have what? We have an induced EMF as well as induced current. Okay, so now what is the change in magnetic flux? Now change in magnetic flux, that is d phi. Okay, and this d phi, if you remember, the formula of magnetic flux is defined as magnetic field times the area. So here, this change in magnetic flux will be magnetic fields times the area of the circular part which has been described by the rod. Or I can say this d phi is equals to B. What is the area in this case? The area here is the area of the circle, which is pi, and then the radius is L, so pi L square. Okay, now let us find out the induced EMF. So the induced EMF is given as E is equals to d phi upon dt from Faraday's law. Or I can say, instead of d phi, I'll write B pi L square. And what is this dt? This dt is actually the change in time. So for a complete one cycle, right? For a complete one cycle, how much is the time taken? The time taken is capital T. So the change in time is capital T. Okay, or I can write this is equals to B pi L square, and instead of 1 upon T, I'll write F, where F is the linear frequency. Okay. Also, I can write this E is equals to B pi L square. Now, if you express this F in terms of, this is the linear frequency, if you write it in terms of angular, it is omega upon 2 pi. Omega here is the angular frequency, or we can say is the angular speed. So instead of F, we will write omega upon 2 pi. So this pi up, pi down cancel. So E is equals to how much? Half B L square omega. So this is the EMF which is induced in the rod. Okay. Number 2. The second part of the question is to find out the induced current. So once you know the induced EMF, then the induced current, right? Induced current can be obtained using this equation. I is equals to potential upon resistance. Okay, But what is the potential in this case? It is the induced EMF E. And the resistance of the rod, it is already given. It is R. So therefore, induced current I is equals to E upon R. So instead of E, you write this value, so you'll get half B L square omega upon R. So this is the induced current. Number 3, we have to find out the heat dissipation. So heat given out, or heat dissipation, is equals to how much? H is equals to E square T upon R. Okay, this is the formula, right? If you go back to class 10, then you will find this formula about the Joule's law of heating effects, where we have heat is equals to V square time upon resistance. But in this case, this potential, it is actually the induced EMF. So instead of V, we write E. Okay? Or you can see, how much is E? My E is equals to this much. So when you square, you'll get 1 upon 4. And then B square L4 omega square. And then T upon R. Okay? So these are the 3 equations about the induced EMF, induced current, and the heat dissipation in the conducting rod.